Welcome to our channel where we dive deep into fireground operations and tactics. Today, we're discussing one of the most critical components of any fire scene: water supply. Whether you're a seasoned firefighter or new to the field, understanding water supply operations is key to successful incident management. Let's break down the guidelines for making effective water supply decisions on the fireground. As the first arriving officer, your initial decisions regarding water supply are crucial. You're essentially trading time for water or water for time. If your initial plan is an offensive fire attack and aggressive search, tank water may be the appropriate plan, rather than the 2 or 3 minutes it could take to lay in from a hydrant. Your water supply decisions will directly impact life safety, incident stabilization, and property conservation. Before committing to any structure fire, a primary water supply plan must be in place. A secondary plan should also be evaluated. Remember, every working fire requires a water supply, and this must be communicated clearly at the strategic level, whether it's established or needed. Effective communication is the backbone of water supply operations. At the tactical level, it's vital to describe the location of the hydrant, whether the initial arriving apparatus has their own water supply or need the next arriving engine to establish it. The route of the water supply apparatus and how the water supply is established. For instance, when level 1 staging is in effect, apparatus staged at a hydrant should broadcast their location upon arrival. For example, engine 5 level 1 at the hydrant at 13th and Tennessee. Let's listen to a typical communication scenario. IC command to engine 5, establish a water supply to engine 1. Engine 5, understood, water supply to engine 1, laying in from 13th and Tennessee. Notice how clear and precise the communication is. This level of detail ensures everyone on the scene knows exactly what's happening. Next, let's talk about the factors you need to consider when establishing a water supply. Here's what you need to keep in mind. Staffing levels, whether you have a crew of 3 or 4. Incident facts versus probabilities, what is known and what is suspected. The size and type of occupancy, access for fire apparatus. Hydrant flow in gallons per minute. Hydrant distance from the scene. Arrival time of the next apparatus. Tank water capacity and the size of the deployed hand line. These considerations will guide your decision on how to establish a water supply effectively. Let's discuss the 4 main choices you have for establishing a water supply. 1. Establish your own water supply using LDH soft sleeve. Usually an engineer can establish their own water supply if the hydrant is within 100 feet of the incident. 2. Forward lay, a common tactic where the level 1 engine lays in from the hydrant to the pumping engine. 3. Reverse lay, where you lay the hose from the pumping engine or the fire scene to the hydrant. 4. Split lay, using a combination of forward and reverse lays to complete the most efficient water supply. Deciding not to establish a water supply on arrival at a working fire means you're trading water for time, and this should be a conscious decision by the fire officer and not just a standard action. This decision should only be made when operating in a high life priority scenario, such as known rescues or searches, or when a clear plan is in place for a continuous water supply by the next arriving apparatus. If the next arriving apparatus isn't close behind, or is a quint or ladder that is needed for truck or aerial operations, the initial apparatus should establish a water supply. This is especially important when dealing with narrow drives, alleys, or when conditions mandate that water supply is a priority. One tactic you can use is the booster backup. This allows you to use 2 tanks of water to knock down or slow the fire. This decision is prioritizing victim rescue or search ahead of establishing a continuous water supply. The second arriving apparatus will then supply the first with tank water using a 5-inch or 2.5-inch line, depending on the situation. Keeping in mind that larger diameter hose may use a significant amount of water just to fill the hose, and smaller diameter to support the first attack line may be appropriate. When dealing with commercial buildings or defensive conditions, especially when using aerial master streams, engines should pump the water supply. Fires in a commercial occupancy should mandate an engine pumping the hydrant, while FDC support may just require a LDH forward lay to the connections. The goal here is to maximize the available gallons per minute from the hydrant. This often requires maximizing the hydrant by using multiple large diameter hose connections to all the hydrant outlets to reduce friction loss and increase the intake pressure on the engine's master intake gauge. The process of maximizing the hydrant involves using no less than 2 large diameter hose connections, one to the main steamer connection and another to the side 2.5-inch connection. Adding a third large diameter hose will further increase water availability. Monitoring the engine's residual intake pressure is crucial during this process. If you can't monitor the hydrant's pressure, the safety rule of maintaining a 20 psi intake pressure is a good benchmark. In conclusion, establishing and managing a water supply is a critical component of fireground operations. Whether you're making decisions about trading time for water, communicating effectively with your team, or maximizing hydrant flow, every decision you make directly impacts the outcome of the incident. As always, stay safe, stay sharp, and keep honing your skills. Thank you for watching. If you found this video helpful, make sure to like, share, and subscribe for more in-depth fireground operation tutorials. We'll see you next time.